Good morning, children. Welcome to VS Reddy classes and VSR classes. Me VS Reddy, and we are going to discuss about the 2 marks questions of 1A. Define symmetric matrix. Define symmetric matrix. And A is given is a symmetric matrix. Find X. A square matrix A is said to be symmetric. Symmetric. A transpose A is equal to A. So here, define symmetric matrix is very important. A square matrix capital A is said to be symmetric if A transpose is equal to A. A transpose is equal to A. Now we'll go for the second problem, that is B bit. That is A transpose we are doing. What is the meaning of A transpose? Already previous in video we discussed about the transform into interchanging of rows into columns or columns into rows is called, it's a transpose. Now A power T. Just you make it transpose, and this is nothing but A, and equate them. This 6 in the place of 6 corresponding element should be equal. Now make it equal, so X is equal to 6, we got it. Now define a skew symmetric matrix. If this is skew symmetric, then find the value of X, he is saying. Now similar to, we have to find write the definition. After that we will go for the skew symmetric matrix. Okay. Now, a square matrix capital A is said to be a skew symmetric matrix if A power T is equal to minus A. A power T is transpose equal to its negative of that function, that matrix, then we can say it is a skew symmetric matrix. Now, if A is given, now A power transpose is equal to this value, we got it. Now, we want minus A here, minus A. Multiply each and every element of that A with negative sign. So minus A is equal to 0, minus 1, minus 4, 1, 0, minus 7, x, 7, 0. Now if you multiply with the negative sign, it becomes 0, and this will be minus 1, minus 4, and equate them. Then we got a 4. In the place of x, what we have? 4. In the place of minus x, what we have? Minus 4. So x is equal to 4 is your answer. X is equal to 4. X is equal to 4 is your answer for that. Now we'll go for the next definition. Now children, see here, determine which matrix this is. Now he is given A is equal to 1 square, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square, 5 square. Directly by saying that if you make the transpose, you got the same value. If A transpose is equal to A, what is the condition? Now this condition holds good for symmetric matrix. This condition holds good for symmetric matrix. Matrix A is symmetric matrix. A transpose equal to A. Now he is given the vertical bars is nothing but the determinant. We have to find the delta. Matrix is different and determinant is different. Determinant can be reduced into a single value, but whereas matrix cannot be. And when you are multiplying with the determinant, you have to multiply with single row or column. Okay. Now here, remember this. Wherever in the matrices, you can multiply each and every element with that element, out of that element. Okay. Now here, now plus, minus, plus. Why you are getting this one means these are the cofactors of that one. Plus or minus you are getting. So 1 into 3x plus 24. AD minus BC. Removing this one and this one. The element 1 is there in first row and first column. Elimination of that one. After that we got the 2 cross 2 determinant. Apply the AD minus BC, we got this value. Minus 0 into anything is 0, no need to find. Plus 0 into anything is no need to find. Is equal to 45. So we can write 3x plus 24 is equal to 45. 3x is equal to 45 minus 24. And 3x is equal to 21 and x is equal to 7, we got like this. Now the determinant value of this one and 45 given, and we have to find the value of x. When x value we got as 7. Now similarly here also, determinant of ABC, BCA, CAB. We have to find the determinant. What is there? Plus, minus, plus, plus, minus, plus. So A into, after eliminating first row and first column, we got the 2 cross 2 determinant. AD minus BC. BC minus A square, we got it this one. Okay. After that, minus B into, after eliminating this element, where that element is present in that first first row and second column, we got these two is the remaining. Now b square minus ac, b square minus ac, we got it. And c is the element where it there that row and that column should be eliminated. This row, first row and the third column should be eliminated. What are the remaining terms? b, c, ca. Now these are the, we have to find the determinant. a, b minus c square. Now we got this one. Just you multiply internally. abc minus a cube minus b cube plus 3 abc minus c cube, we got it. And if in order, 3abc minus a cube minus b cube minus c cube, you got it. Take the minus common, you will get a cube plus b cube plus c cube minus 3abc. Like this also you can left, like this also you can write, as you wish. Okay. Now here he is given the other problem without expansion. Without expansion means like this we can't do, like this we can't do. Without that expansion, we have to prove that this determinant is equal to this determinant. Like this we have to prove. Remember this word. Without expansion means if you do with expansion, they will not give the marks also. Okay. Whenever he mentioned the without expansion word. Okay. Now we'll go for that. Ax plus by plus is equal to cz, x square, y square, z square, 1, 1, 1 is given. This is the determinant. What I am taking is, we have to take a common from one column, one row. Okay. Similarly, I am taking x common from C1, x common from C1. Whenever we are taking common, here common is there, here x square is there, common is there, here it is not there. Wherever it is not there, it divides. It divides. So, a x 1 by x we got it. A x 1 by x we got it. A x and 1 by x we got it. A b c x y z 1 by x 1 by y 1 by z, like this. If I take x common from this, there it is not common, there it divides. Here it is not common, there it divides. Here it is z is not common, there it divides. Taking x common from C1, y common from C2, z common from C3. Now we get x, y, z. A, B, C, x, y, z, 1 by x, 1 by y, 1 by z. Like this is equal to, now A, B, C, x, y, z. I can multiply this element out of the outer element with one row or one column. I chosen that is third row. Now if you multiply this one, x, y, z by x, x, y, z by y, x, y, z by z, we got it. Now if you remove it, cancellation, after cancellation you got a, b, c, x, y, z, y, z, z, x, x, y. This is the remaining part. What we have to show? This, by taking this value, we have to prove this one. Without expansion. We did without expansion only. Without expansion, by taking the properties of rows and columns, now we do this one like this. Now listen. Construct a 3 cross 3 matrix with the relation Aij is equal to half of I plus j. He is given this relation I plus j. What is I? Ith row and jth column. The I is nothing but the ith row. I denotes the rows and j denotes the columns. Okay, remember this one. We have to construct 3 cross 3 matrix. Let 3 cross 3 matrix will be of the form like this. A11 means first row and first column. A12 first row and second column. A13 first row and third column. Similarly, I can write like this, and by substituting A11 means of 1 plus 1. In the place of I, 1 is there. In the place of j, 1 is there. So 1 plus 1, you got 1. And A12, in the place of I, 1 is there. In the place of j, 2 is there. Of 1 plus 2 is equal to 3 by 2. And A13, that is equal to of 1 plus 3 is equal to 4 by 2. We got a 2. A21 is in the place of I, 2 is there. In the place of j, 1 is there. Of 2 plus 1, that is 3 by 2. Similarly, if you find like this up to here, we got these values A23 and 1 by 2, 2 plus 3, 5 by 2. And A31 of 3 plus 1, that is 2. Like this, we got the 3 cross 3, 3, 3, 3. And of 3 plus 3 is equal to 3. Now, these values, you have to substitute this one. So 1, 3 by 2, 2, 3 by 2, 2, 5 by 2, 2, 5 by 2, 3. This is your required matrix for that relation. He may give different relations also, no problem. I took this relation, okay. Now we will go for the next one. A is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3. find a power 4. Okay, don't multiply a power 4 means 4 times. First of all, we will find a square. After that, a square into a square, it becomes a power 4. No need of finding, because if I take a3 common from that, it becomes an identity matrix. Whenever he is given identity, very easily we can calculate it. Identity matrix. A is equal to 3 common. It is a matrix. We have to take the common element from each and every row. Each and every row. Okay. Now I took 3 common. We got identity matrix like this. Now raising the power 4 on both the sides. A power 4, 3 power 4, 1 0 0 0 1 0 0 0 1 whole power 4. Like this we got. And 3 power 4 we know that is 81. And this is the identity matrix. If you multiply identity matrix with identity, I into I or A into I, you will get A only. Okay. Due to that reason we are saying that that is identity matrix. So this is identity matrix. If you any number of times if you multiply, you will get the same identity matrix. So 81 into this identity. So 81 0 0 0 81 0 0 0 81 is your result for A power 4. Okay. Next, show that A transpose is A transpose, product of A transpose is symmetric. Is symmetric matrix we have to prove. What is the condition for the symmetric matrix? A transpose is equal to A transpose is equal to A. Now I will take this element as B. This element as B, and we will get B is equal to A transpose. A transpose. What I have to prove? Now దీన్ని B తీసుకున్నా కాబట్టి RTP B transpose equal to B అని ప్రూవ్ చేస్తే సరిపోతుంది నాకు. I can prove that what is RTP? B transpose equal to B. We have to prove like this. Then only we can say that this total B is a symmetric matrix. So B transpose I took. A transpose whole power T. We have the formula AB whole transpose is equal to B transpose into N transpose. B transpose before first you write B. So in the place of B what is there? A transpose is there. Go off writing A power T and A power T. So you will have A transpose whole power other transpose gives A itself. So A transpose. Again we got like this. What is this B? This is nothing but B. Now B transpose is equal to P. B transpose is equal to P proved. Hence A dash is symmetric matrix. Symmetric matrix. Like this we have to prove. Whenever he is asking to prove that without doing means he's given the show that prove that means like this you have to prove. Now listen children. He is given det of A minus B, B minus C, C minus A, B minus C, C minus A, A minus B, C minus A minus B, B minus C. We have to find the determinant of this one. Or simply he will give the bar lines, like this vertical bars. Between any number is between the vertical bars, we have to find the meaning is we have to find the determinant of that matrix. Determinant of that matrix. I didn't wrote all the things and I will put the vertical bars. Like this definitely you will give. Okay. Now I will make use of the rows and columns. Now I am using R1 is equal to R1 plus R2 plus R3. If you add it, if you expand plus minus plus like this also you will get it is bigger expansion. Okay, it is a 2 marks question. You have to do within short period. R1 is equal to R1 plus R2 plus R3. Adding R1, R2, R3 to R1. Row 1 ni R1 కి యాడ్ చేస్తున్నా. రో 1, రో 2, రో 3 మొత్తం. ఇప్పుడు రో 1 లో ఏముంది నాన్న? A minus B adding this one with B minus C plus and a plus C minus C. Like this we got it. And for this also B minus C, this we added to this one, this is also added to this one. Now by cancelling all the things, we got 0 0 0, B minus C, C minus C, A minus B, C minus A, A minus B, B minus C. Okay, have you understood this? Now 0 0 0 we got it, and the remaining values like this. What we have in a det, one row or one column. Det means determinant. Okay, I wrote in shortcut. No problem if you write like this also, they will give the marks. Okay, column in 0 is 0 is 0. Its det is also 0. Is goes to 0. Its det is also 0. Its determinant value goes to 0. If you want to find like this also, you can find it. Definitely you will get 0 itself. Okay. Now next, if A is equal to 1 minus 5 6 2, 1 minus 5 6 2. find adjoint A and A inverse. We have to find both the values, adjoint A as well as A inverse also. If A is equal to A, B, C, D, we have the formula like this. Det A is AD minus BC, we know that. Okay, I took the value also. This will be 2 minus of minus plus 30, it becomes 32. Adjoint A, just you interchange D here, A here, and put the minus signs for the remaining non-diagonal values. Okay, this is the principal diagonal, this is the other diagonal. Okay, now A inverse is equal to adjoint A by det A. We know this formula by our proof also. And 1 by 32, that is 2. Replace D here, 2, and A should comes here, and minus of minus B, minus of minus 5, it becomes 5, and 6 minus 6. Okay, like this we got the value of A inverse is this thing. Next, third one, A 0 0 0 B 0 0 0 C is given. Okay, directly we have to find the determinant of this one. And if you see properly, this is the upper triangular matrix, and as well as this is lower triangular matrix. So if you find the determinant like this, you got ABC. Okay, remember this word, whenever he is given upper triangular or lower triangular matrix, its product of its diagonal elements is called your determinant. Product of its diagonal elements here, Y, B, C, and here, or product of the principal diagonal elements, because it is a upper or lower triangular matrix. Whenever it is upper triangular or lower triangular matrix, its diagonal, the product of its diagonal elements is called your determinant of that matrix. ABC, that you got ABC as a product ABC. Okay. In the similar manner, or if you don't know that one, you go for direct expansion. Very easily you will get it. Okay. Now we'll go for, now children, see here. Define singular and non-singular. Define singular and non-singular matrix. Prove that this 1 1 1 1 1 1 1 1 1 is a singular and inverse does not exist. We have to prove that it is a singular as well as inverse does not exist, and prove check. Okay. Now what is the definition of a singular matrix? A square matrix whose det means determinant. Det is equal to 0. Det is equal to 0. Then A is called singular. That is I dot E det A is equal to 0. ఓకేనా, ఒక డిటర్మినెంట్ యొక్క 0 అయితే దాన్ని సింగులర్ మ్యాట్రిక్స్ అంటారు. ఓకేనా, ఇఫ్ det A is not equal to 0, then నాన్ సింగులర్. ఓకే, మళ్ళీ అది నాన్ సింగులర్ గా రాయాలంటే ఏ స్క్వేర్ మ్యాట్రిక్స్ హూజ్ det is not equal to 0, then A is called నాన్ సింగులర్ మ్యాట్రిక్స్ అని చెప్పేస్తాం. ఓకే, లైక్ దిస్ ఆల్సో యూ కెన్ మెన్షన్, నో ప్రాబ్లం. ఓకే, now we'll go further. Now A is equal to 1 1 1 1 1 1 1. Let I assumed as that is A is equal to, what is its determinant value? Is 0. Why means, in our according to properties of the determinant, one row and one column are identical. In a matrix or in a determinant, one row or one column is identical. Then its determinant goes to 0. Then the determinant goes to 0. Here, one row, one column, and third row, third column is also identical. Identical ante same undal nana. So same. So we can answer is goes to 0. So that A is equal to 0, then A is a singular matrix. Singular matrix. అయిపోయిందా? For singular matrix, inverse does not exist. ఎందుకు? Inverse is undefined. ఎందుకంటే formula inverse, now only we discussed in the previous video, is 1 by, that is adjoint A by det A. What is det A here? 0. If you put 0 here, it goes to infinite, so undefined. Have you understood? I hope you can able to understand all these things. Okay, and you have to write like this. Whenever he is asking the definition properly, you have to write, then only you will get the 2 marks question. Why? Because in 2 marks question there is no choice for you. Now listen children. Rank of a matrix. We have to find the rank of a matrix. Before that, we have to go for the rank definition also. One go through it, and the rank definition, what it says, I will explain. I will try to explain one example. Okay, remember this. We have no time, that much time is not there for it. 1 is equal to A, 1 2 3 4. This is the matrix A, and B is given 1 0 0 1 0 2 0, and C is given 0 0 0 0. Okay, for these problems, we have to find the rank of a matrix. First we will find this is 2 cross 2, this is also 2 cross 2, and this is also 2 cross 2, and further we will discuss about the remaining values. Okay, 2 cross 2. Det A is equal to 4 minus 6, we got the determinant minus 2, which is not equal to 0. It's a non-singular matrix. Whenever the non-singular matrix is there, the highest, its order is itself its rank. Rank of A is equal to 2. What is its order? 2 cross 2. Highest is nothing but 2 cross 2. That is rank 2. After that, we will go for the B bit. Det A is equal to 0. Whenever det A is equal to 0, is a singular వచ్చిందో, singular వస్తే 1 cross 1. Check at least 1 cross 1 square matrix is a non-singular కాదా చూసుకోవాలి. అంటే ఇది 1 ఉంది. 1 is a square matrix అమ్మా, గుర్తుపెట్టుకోండి. 1 is a square matrix of order 1 cross 1. ఇది కూడా స్క్వేర్ మ్యాట్రిక్స్. ఒక సింగిల్ ఎలిమెంట్ ఉంటే అదొక మ్యాట్రిక్సే. రిమెంబర్ దిస్ వర్డ్. 1 cross 1 is also a matrix. Element 5, 2, 10, minus 10, 5/2. These all are singleton matrix. That is 1 cross 1 matrix. Okay, remember 1 cross 1, which is not equal to 0. 1 is there, 1 not be equal to 0. 2, 1 cross 1. At least 1 అన్నాడు వాడు. At least 1 of 1 cross 1 square matrix is non-zero. ఒకటి ఉంటే చాలు, మనకి ఇక్కడ 2 ఉన్నాయి, no problem. Therefore the rank of A will be 1. దాని కాడికి ఒకటి తక్కువ ఉంటుంది. So 1. Now the last one. This is 0, 0, 0, 0 square. Det A is equal to 0, singular. దీనికి కూడా అలానే. There is no 1 cross 1 non-singular matrix. అసలు 1 cross 1 అనేది సింగులర్ మ్యాట్రిక్స్ గా లేదు. ఇగో 0, 0, 0 ఏదైనా సింగిల్ 1 cross 1 తీసుకుంటే 0 అవుతుంది. Therefore the rank A is equal to 0. Like this we have to go further. Now we will go for the discussion of rank of a rectangular matrix. This is a rectangular matrix. How can you say that this is rectangle? 2 cross 3. Okay, rectangle matrix count. అది ఇలా నిడివిగా ఉండొచ్చు, ఇలా అడ్డంగా ఉండొచ్చు, నో ప్రాబ్లం. ఓకేనమ్మా. Now we will go for, let me take this as A. సబ్ మ్యాట్రిసెస్ అంటే దాంట్లో నుంచి ఒక 2 ముక్కలు చేసి తీసుకోండి. నేను ఈ భాగం ఆ భాగంగా తీసుకుంటున్నాను. ఐ విల్ టేక్ దిస్ పార్ట్ అండ్ దట్ పార్ట్. 1, 2, 4, 5 ఇగో ఈ భాగం. నా 2, 3, 5, 2 ఆ భాగంగా తీసుకోండి. 2, 3, 5, 2. సార్ మీరు ఇట్లా తీసుకున్నారు, నేను 1, 3, 4, 2 తీసుకుంటా. తీసుకో, నో ప్రాబ్లం. ఇంకొకటి ఎక్స్ట్రా అవుతుంది అంతే తప్ప, నీకు మాత్రం సేమ్ ఆన్సర్స్ వస్తాయి. నా సబ్ మ్యాట్రిసెస్ A is equal to 1, 2, 4, 5. And that A is equal to -1, which is not equal to 0. It is a non-singular. Therefore the rank of B will be depending in its order, that is 2. Now C is equal to 2, 3, 5, 2. That C is equal to 4 minus 15, that is equal to non-singular. Therefore rank of C is also 2. Now what is the rank of A we want, not rank of B and rank of C. That's we assumed, for our convenience we assumed B and C. Okay, it is not B and C. We have to get the rank of A. ఈ A యొక్క ర్యాంక్ కావాలి మనకి, అంతేగాని B కి C కి కాదు.